and then I'm going to be done. Okay. So we'll do the reciprocal function this time. F of x equals 1 over x. And then g of x equals maybe like the square root of x minus 3, let's say. Those are the two we'll work with. So each one of these has got its own domain issue going on, right? One involves a division issue, one involves a square root issue. So reciprocal function, who can give me that domain to start off with here? Yeah.
Negative infinity to 0, not including 0. Union 0, not including 0 to infinity.
Yeah, good. Okay. And then somebody else, what about the square root then? It's the square root of x minus 3. So I always start with this. Can I put a 3 in? Yeah, you can, right? Because it'll just make it 0 and square root of 0 is 0, and that's okay. Can I go bigger than 3? Sure. Can I go less than 3? No. So what's the domain? Other way. I got bigger, right? The bigger numbers work. The smaller numbers didn't work, right? So including 3 and up are okay. That's the domain. Okay, so let's try position work here. So how about f of g of x? So I'm going to dump g into f. So 1 over the square root of x minus 3. So that's where I'm at before I simplify. Can I simplify on this one? Not really, right? If I wanted to rationalize the denominator, okay, but it's not really anything you need to do. So we can just analyze it right here. Just see what you got. So what numbers will work in that particular function the way that it's written? Do I include the 3? I can't include it now, right? Because what happens if that square root comes out to 0? Then I'm dividing by 0, and that's a problem, right? So not including 3 to infinity for that one then. Okay, you have to kind of follow it through. What happens if it's 0 and work with that. Okay, the other way, g of f of x. So now I'm going to have the square root of 1 over x minus 3. And can I simplify that thing at all? Not really. Nope. So again, just take a look at what you got, analyze it. What numbers will work in there? Start with the 1 over x. What number is bad there? 0. So automatically can't use 0. Okay. I also have this square root over the whole thing. So the result of this is going to have to be positive or 0. The result of the whole thing needs to be 0. 0 or larger. So this one you might not be able to do in your head. Okay. So here's a little trick you can use sometimes with ones that get a little extra tricky like this one. 1 over x minus 3 needs to be greater than or equal to 0. Agreed? What's under the square root has to be greater than or equal to 0, right? Solve the inequality. Okay? So let's take this the rest of the way. So 1 over x needs to be greater than or equal to 0. Or 3, sorry. Add the 3. Okay, so what values of x would make 1 over x greater than or equal to 3? So including 3 to infinity. So if I plug in a 3, is 1/3 greater than or equal to 3? Does that work? Nope. Yeah, well, the thing is with inequalities, as soon as you start multiplying x's across the inequality symbol, things get screwy. It doesn't necessarily switch. If x is a positive number, it doesn't switch. If x is a negative number, it does switch, and we don't know which it is. So that's a little bit tricky to do. So we're not going to do that. It's better to just kind of think about it right now. So let's start with this. What makes it equal to 3? What value of x makes this thing equal to 3? 1/3. Okay, so something's going on with 1/3. So it's either got to be greater than 1/3 or less than 1/3. Okay, so if I start picking numbers that are bigger than 1/3, like 1, does 1 work? No. Okay, try numbers that are less than 1/3. So like 1/4. Would 1/4 be greater than or equal to 3? Sure. What if I bring it all the way down to 0? Is 0 okay? 0's not okay. Okay, what if I skipped over 0 and went negative? Does that work? No. So where am I locked in here then? 0 to 1/3. Not including 0. Yep. Okay, so my domain then, not including 0, 1/3. Do I include the 1/3? Yes, you can. Yep. That's about as tricky a domain as you're going to get. Okay? I didn't anticipate that one getting that difficult, but you can reason it through that way, but it is tricky. It is very tricky to do. Most of your homework, in fact, I think pretty much all your homework is not going to involve anything quite to that level. One other thing that I wanted to do, just so you have practice doing it, it's pretty simple, but we're going to use this example as a way of doing it. Let's say I wanted to know f of g of, let's do, how about 7? So can you evaluate a composition? 2 ways to do it. G of 7, I could go back to my original g of x equation, plug in a 7, and then take the result of that and plug it into f. Okay? Or I can take my new formula I just came up with and just plug it in there and go, which is usually how I do it because it tends to be simpler. So f of g of 7, okay, so here's our equation for that, 1 over the square root of x minus 3. So 1 over the square root of 7 minus 3. So that would be 1 over the square root of 4. So what would be my final answer there for that? 1/2. Okay, then let's say I also wanted to do g of f of, now this one I got to choose something that's between 0 and 1/3, so let's do 1/4. That's between it. Okay, so I have the square root of 1 over 1/4 minus 3. Okay, that's with the number just plugged into the final formula here. Okay, so what is 1 over 1/4? 4. Okay, it's the reciprocal of 1/4, so it's 4. So square root of 4 minus 3, and suddenly it's like, oh, that's easy. What's the square root of 4 minus 3? 1, because it's the square root of 1. So that answer is 1. Okay, so evaluating, pretty straightforward. Okay, all right, stop recording.